Okay, guys, let's begin our discussion of 9.5 here, tangent and cotangent functions. Before y equals sine x and y equals cosine x were sinusoidal in nature. They made a wavelength form. Now we're going to look at the tangent function. In other words, we're going to graph tangent as a function either of, say, distance or time. Okay, now the key thing we want to look at the beginning here is that the tangent of x equals sine x over cosine x. And if we did say the cosine of pi halves, well, what's the cosine of pi halves? And maybe it was sine of pi halves over the cosine of pi halves. Well, pi halves is a 90, and at 90 your y value is 1, your x value is 0, and hence it's undefined. So the tangent of x is the graph is defined by these undefined portions, which are vertical asymptotes. So every time there's a vertical asymptote, remember, is where it's undefined. And that's when our graph is going to approach but never reach that imaginary line that exists at that location. Okay, the other key idea for tangent functions that before on our sine and cosine, our period was 2 pi over b. And notice the period, or the time it takes to complete one cycle, in this case of a tangent function is pi over the absolute value of b. Okay, so with that knowledge in mind, we're going to now look at y equals a tangent b of x, and we're going to graph, and we'll start with our parent function, y equals tangent of x. And remember, a here would be 1, and b here would be 1, because if there's nothing showing, we assume it's a 1, right? Okay. So vertical asymptotes are at odd multiples of pi over 2b. So pi over 2 times absolute value of 1. Absolute value of 1 is 1, multiplied by 2 is 2. Pi over 2. So I know that I have a vertical asymptote here at pi halves. And I also have a vertical asymptote at, say, an odd multiple of it. Say, well, pi halves times 1 is pi halves. We have that one. How about pi halves times 3? Well, 3 pi halves. And that really would be out here. I extended my graph. Three pi halves. And I can go ahead and dot that in. Again, draw those asymptotes first. X equal to pi halves, x equal to 3 pi halves. Could I do the negative? Could I do a negative odd multiple? Sure. Let's say pi halves times negative 1, which is an odd number, just like 1 and 3 or 5. Well, negative 1 times pi halves is negative pi halves. And that's x equals negative pi halves. Okay, so we want to begin with these vertical asymptotes because, again, they're going to define our graph. And if we begin with them first, it'll be easier to do all of the rest of it. Okay, so another thing we want to notice here is that our period, instead of being 2 pi, as it was with our sine and cosine graphs, but our period distance or time in this case is pi. Okay, from negative pi halves to pi halves is pi. And also we have this quality of the tangent graph being offset. Typically when we looked at, say, a sine graph, well, it started here, right, at the y-axis if there wasn't any horizontal transformation, right? And say it did something like that, right? And we drew it. Or also if we did, say, a cosine graph, it also started at the y-axis here for our parent function, unless it had a horizontal transformation, a phase shift. And it did something like this. Well, now instead of it, say, starting at the y-axis, well, it's now offset from the y-axis. In other words, the period takes place equally on either side of the y-axis here. So my period starts here at negative pi halves, and it goes up to pi halves. So we want to keep that in mind with tangent functions. This is one of the major things that trips students up. They're used to just starting at the y-axis and going from there. Well, no. Once we find whatever the period is, well, we divide it over pi over 2b to find those asymptotes. And we're going to find that our graphs is going to take place between those asymptotes. Well, what about these locations here, Mr. Hess? Well, good question. Well, if I want to find those out, I know that 0 plus pi halves is pi halves. And if I divide that in half, that's the same as multiplying by a half, right? That's pi fourths. So this location here is pi fourths. And also, this location would be negative pi fourths. So we want to find those intermediate locations in between our asymptotes. And we can do that by taking whatever that first asymptote location is and essentially dividing it in half again. And then, of course, we have a location of 0. Okay. Okay, now, again, this would be our amplitude. And this would be our B, right? Again, that would be vertical stretch or shrink. And this would be horizontal stretch or shrink of 1 over B. Okay, so let's get about graphing these and let's evaluate a few points. Because once we have our asymptotes and we've kind of determined what our intermediate locations are, let's evaluate a few of them. Okay, let's evaluate, say, negative pi fourths to start here. So, and again, that would be our XY table. Negative pi fourths, 0, and pi fourths. And we've already got the other locations, which are our asymptotes. Okay, so let's evaluate one of these. Y equals the tangent of negative pi fourths. Well, the tangent of negative pi fourths is really the tangent of a 45-degree angle, or in this case, a tangent of negative 45 degrees. Well, if we think to our unit circle, we could, of course, think of our original triangles, or we can think of it on the unit circle. And a 45, we remember that had side lengths of the same length. Okay. X over y, remember, tangent again is sine over cosine or y over x. Sine over cosine. So the tangent of a negative 45 well, that would be on the unit circle, let's say. That'd be positive root 2 over 2 over, nope, negative root 2 over 2 over root 2 over 2. Of course, we'd invert and multiply. 2 over root 2, cancel, 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 equals negative 1. And remember, if you like thinking about it with the original triangles, and that way's easier for you, then use that method. If you like using the unit circle and you think about it easier that way, use the unit circle. Okay, so tangent of negative 45 degrees is negative 1. And this would be negative 1, negative 2, positive 1, positive 2. Okay, so at negative pi fourths, we're at negative 1. And I just went ahead and plotted it. Let's do now the tangent of 0. Well, again, that's sine over cosine. Well, what's the sine at 0? Well, the y value, again, y over x, too. The y value at 0 on the unit circle is 0. And the x value is 1. Well, 0 over 1 is 0. And let's do the tangent of pi fourths. Maybe you just want to think about your original triangles here. Sine over cosine, y over x. 1 over 1, it's just a 45 in the first quadrant, so that's 1. Okay, so let's plot those, 0, and then at pi fourths I'm at 1. Okay, and then I'm going to draw my graph, and it's going to look something like this. Okay, so notice, it goes through 0, 0. At negative pi fourths, my y value is negative 1. And at pi fourths, my positive value is at positive 1. So essentially, that's my, you got it, amplitude. Okay, so let's do another period length of it just to be sure we can do that. Okay, so let's now just do another period's worth here. And again, pi fourths. If I want to determine, say, how much I'm adding here to pi halves to 3 pi halves, in other words, what are these intermediate locations along the way? Well, then I can go back to the beginning. I went from 0 to pi fourths. So that's how much I'm adding each intermediate length. And pi fourths plus pi fourths is pi halves. So I'm going to want to add this value of pi fourths to wherever I'm at. And we'll go from there, pi fourths. Well, pi halves plus pi fourths, if I multiply by 2 over 2, that's 2 pi fourths plus pi fourths, 3 pi fourths. So I know that this here is 3 pi fourths. And then 3 pi fourths plus another pi fourths is 4 pi fourths, or pi. And then pi plus another pi fourths, well, that'd be 4 pi fourths plus pi fourths, which is 5 pi fourths. And plus another pi fourths would be 6 pi fourths, or 3 pi halves. So we've got, again, to our other asymptote there. Okay, again, and now it should be easy. We know that in the middle, pi should be at 0. 5 pi fourths should be at our positive amplitude of 1. And 3 pi fourths should be at our negative amplitude of -1. And then again, I draw my shape. And notice it mirrors my other shape. Okay, and of course we could then, if we were going in the negative direction, we could do negative pi halves here minus another pi fourths. And I'll go further negative, and I'll find each intermediate location until I get to my next asymptote. Again, and remember, the vertical asymptotes are odd multiples of pi over 2b. Okay, so that's again our parent function, y equals the tangent of x. And this is going to be the behavior of tangent as, say, we went around, say, the unit circle in a cycle. But notice our period length here is pi instead of 2 pi, and that it's also offset. In other words, it doesn't start here at the y-axis, but it's offset, and the y-axis is instead in the middle of the two asymptotes that define the graph.